Hi class, welcome to this video on section 5.6, connecting variation, slope, and first differences. And we're going to start by looking at this table of values that you can see on the screen here, which is taken from page 279 in your textbook. This table of values shows the height compared to the ground of a snail as it crawls up a pipe, and that is over time. And the first thing we're going to do here is we're going to graph the relation. And we're going to graph the relation over here, and then we're going to address whether it is direct or partial variation. So if we graph the relation, we can do that together really quickly here. The first point is 0 and -3. You can see I get that from here. Then 3 and 1, 6 and 5, 9 and 9, and 12 and 13. Okay, and so then we would draw a nice straight line through it. Hopefully you have a ruler and can do it a little bit better than I can. Now we answer the question, is this direct or partial variation? We could see that it is partial variation because the line does not go through the origin. It starts below the origin in this case. Okay, so this would, in this case, would be partial variation. It says describe the pattern in the t-values. Use first differences to confirm that the relation is linear. So if we look at the pattern in the t-values, you can see that they're going up by 3 each time. And then if we look at the first differences over here, we can see that it went up by 4 each time. Okay, so t-values increase by 3. And first differences are all 4. Alright, we can confirm that this is a linear relation because the pattern in the t-values is the same and the first differences are the same. Therefore, it is a linear relation. Calculate the slope. And so we'll use the graph to initially do that. If we calculate the slope using the graph, we draw a right triangle from any 2 points which we can clearly identify. So if we do that here, we see we go from -3 to 1, we get 4. And we go from 0 to 3, and we get 3. So that would make the slope rise 4 over 3, or 1.333, and so on. Okay. How does the slope relate to the first differences and the pattern in the t values? Well, you should be able to see I got 4 over 3 here, and that 4 connects to the change in y here in the table of values. And the 3 connects to the change in t, or the pattern in the t values. So what you could say is that we did the slope, or sorry, 4 is the change, 4 over 3 change in y, and 3 is the change in x. Alright, then what is the initial value of the height? So the initial value of the height is going to be the height, or the y value, when the x value is 0. So in this case, when the x value is 0, t, the height is -3. So that's your initial value. And in this case, it would mean they started 3 meters below the below ground. Equation for this line. So when we write an equation in the form y equals mx, or y equals mx plus b. In this case, we know it's partial variation, so it's y equals mx plus b. The y is the height, so we can write h for that. The slope we determined was 4 over 3. And then x is the independent variable, which is t, and the initial value, which is b, and we get -3. So h is equal to 4 over 3t minus 3. All right, and that is your equation. And anytime you're doing this, that's all you're doing. You're thinking, what is the independent variable? The dependent variable. The dependent variable in this case is the height. The x is the independent variable. In this case, it's time. So you have your height and your time for your variables. And then m is your slope, 4 over 3 we found. And then b is your initial value, which is -3. All right, so that sums up the first problem here, and I would encourage you to reflect on this, and I want you to do your best to think about how these things are related. And I think we've done a pretty decent explanation already, but I want you to reflect on it for yourself as well. All right, moving on to calculating slope, and we've actually already covered this in class, and you've already had an evaluation on this. And so what I would say is, if you're unsure about this, I'm going to be posting this link next with the video, and if you're unsure about any of that, you can go there and check, and then you should be able to figure it out from there. All right, let's look quickly at example number 1 here. It says the graph shows the relationship between the height of a parachutist in meters, it should say, and the time of descent in seconds. Find the average rate of change or slope of the height. So if you're finding the slope, you're going to take 2 points you can clearly identify. Here we have 2 points we can clearly identify. The rise here is 100. The run here is 20. Rise over run, 100 over 20, and we get a slope of 5. But we should notice something, that we went down when we went from 500 to 400. So this is a negative 100. And negative 100 divided by positive 20 gives us negative 5. So our slope is negative 5. It says, explain the meaning of the average rate of change and the slope in this situation. Well, what it means in this situation, because we have a parachutist and we're measuring their height over time, it means that the parachutist is descending at a rate of 5 meters per second. So a descent of 5 meters per second, and that's what it means in this situation. This is write an equation for this relation. Again, start off by thinking to yourself, y equals mx plus b. What is the dependent variable in this case? It is, again, height. What is the slope? We found the slope was negative 5. What is the independent variable? It's s for seconds. What is the initial value? The initial value is also the y-intercept. It's where the line connects with the y-axis. In this case, it's 500. So here is our equation. All right, now I'm going to look at very quickly this here, example 4, rule of 4. A relation can be represented in 4 ways as shown below. In terms of the other questions on this handout, I will be posting like an answer key, so you can do them on your own and then check the answer key and see if you've done them correctly, and if you have any questions you can ask me. But in this video, I'm just going to go over this part here. It says here, Jacques earns $25 per day plus $9 per 100 flyers for delivering advertising flyers. This is an example of using words to describe a relation. Use the rule of 4 to describe this relation in 3 other ways. So you had a very similar question on your last evaluation that some of you actually had a little bit of trouble with, but that's okay. We're going to work it out today. So if you look at this, it says here it's $9 per 100. Well, to find the slope, we need to find out what the change is per 1. How much is he going to get paid for delivering 1 flyer? And so the way that we would find that is by doing the amount that he gets paid for 100, which is $9, divided by 100, and that gives us that he gets paid 0.9 cents, or 9 cents, not 0.9 cents, 9 cents per flyer, and that is going to be your slope. Your initial value is how much he gets paid for just showing up to start work before he delivers any flyers. So that's going to be your B. So if I write my equation here, we're doing earnings is the dependent variable. That's what we're trying to calculate. 0.09, because 9 cents per flyer. We can do N for the number of flyers that he is delivering, plus 25. And we have our equation here. Now, when we do the numbers, the table of values, we're going to the independent variable, an x value here, and a y value here, a dependent variable here. So this x represents the number of flyers, and the y represents the earnings. Okay, and I made it go up by 100 so that the values would be a lot easier to work with. So if we're filling in this table of values, think how much does Jock get paid for delivering 0 flyers? He just showed up at work. He gets his $25. And then how much does he get paid for 100? He gets paid $9, but we have to add that to the initial 25 that he got. So we got $34. And then 43, and then 52, and then 61, and then 70. All right. And so then now we could graph this relation over here, and we would graph this by getting 0 and 25 is our first point, 134 and 243. And you can see it's going to be a little bit not precise, but it's okay. It's really close enough. And then 352. And then 461. And then 570. And you can see now that we have graphed, and we should have what amounts to a straight line. Now my graph is also missing a title, labels. Make sure you include those in your own graph. But here you can see the rule of 4. That is, we've represented the relation in words, equations, numbers, and graphs. All right, in terms of the rest of this handout, I'm going to come back to this part of the handout when we do the next unit on Unit 6 in the textbook, Unit 7 in the course. And in terms of homework, instead of doing questions 1 to 13, you could do questions 6 to 8 and question number 13, as well as I'll have a short little quiz to go along with this video. I hope everything is clear. If you have any questions, feel free to reach out to me anytime.